All right. You were saying?
Yeah, I was able to use the LinkedIn APIs. That's interesting.
Yeah. How was that? I saw you posted testing APIs and
Yeah,
then
so like in order to upload an image to a post, you first need to send a request to LinkedIn, say, hey, I want to upload an image, and then they're gonna send you a link back. Then you upload the image, and then then they send you image ID or something like that, and then you create a post by attaching also the image ID as a media. So yeah, it's kind of a long process to do.
so you're gonna hook it up to GPT-4 and then you're gonna automatically post.
Yeah, I want to try to do that. So like my idea is I'm gonna scrape the papers with code trending page. I'm gonna store each title in a database, so I know which one I've already seen, and then I guess I can just take the abstract and say to GPT, hey, make this a LinkedIn post with some emoji and stuff, and then for the image I can either like go on the pager, go on the paper page and screenshot that and create that as an image, or I can like have a way to instruct a model, say, I need you to create a JSON file with, a title, etc. And then I automatically create an image, using some code that will just, like create an image with, I don't know, some gradient and new model, blah, 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 etc. Or I can try to look if there is a GitHub page and take the first media in the README. That usually is, the one with either a video or an image or whatever. But I guess it's just easier to screenshot the paper itself, I guess.
Well, it sounds interesting. Let me know what you find on that. Or what
you will see that if I'm able to pull that off.
Yeah. So I mean, like for people, because we're gonna upload this later, right? So like for people that are watching, this is gonna be paper time with Francesco. We're gonna go through like we collected, or I sent you like some papers that I thought were interesting, but we can look at any paper you want, really. Like the idea I had was basically, I mean, you can do this in different templates, I guess. Like you could do like a more deep understanding of a single paper, and we might do that maybe in the future. But I was thinking like today we could be okay with sort of going more shallow and trying to understand more broad papers and like having an understanding of what they essentially did, like the most like, so we don't look at very in depth, but we look at a few different papers and get an understanding what happened in ML these last 3 weeks or so.
Yeah, sounds good. Yeah, so
and
I think
we'll see how it goes.
A list, right?
Yeah, so I have a list, and we'll see how this works. Like this platform, you're supposed to be able to share screen, and so we can share when we go through the paper. You can share your, and we can, or I can share mine, and we go through it. And this is the first time I've done this, so we'll see how it goes. But it's a interesting thing because like there are so many things happening in ML, and I think just following, first of all, like following, like you can't go deeply on every paper, but just being able to get an idea of what's going on, I feel it gives a lot. And then depending on the project you're doing, depending on the work, you go really deep on that specific area. That's sort of my strategy currently for understanding, and keeping up to date with ML.
I basically do the same thing, right? So like, I mean, at least I try to go very quickly on a paper, because like usually when people share that, around social media stuff, they are usually like try to build up some hype or cherry picking some specific part. So sometimes like something seems like super cool, etc. But then maybe, there are also limitations. You don't really know if you don't go through the paper, etc. So yeah.
Yeah, and there's a lot. So let's check. Which one do you want to start with? Look, we created a list. Let's see. So
yeah, so like in my brain, I guess it works in a weird way. So I remember the list from the bottom to top. So I remember like you had DINOv2, segment anything, you had mini GPT-4, you had the web paper with 1 million tokens, and then something else in the middle.
What papers have you read recently, by the way, that's been sort of interesting to you?
So the last one I read with people on my Discord, I think it was DINOv2. Yeah, that was interesting. And then we also try to recreate the video that they have, with the dog. That was kind of, was running in a field, and then they show the first three components of the PCA, in different colors, etc. But that was very hard to reproduce. So that was interesting thing that we try to do. I still have to read the segment anything paper. No, wait, I read that, but I think in your list you had the TrackAnything, right? Yeah. So that was also on my reading list. That would be interesting to have a look at. And then I also read mini GPT-4. If I remember correctly, 2 on your list are the ones that I already, read a little bit about. Maybe we can have a discussion about these 2 papers.
How did by the way, like, did you read the Jan LeCun, or I guess it wasn't Jan LeCun, but the self-supervised cookbook?
No, it's there on my reading list. I just read the part about performance, and they have like a little section or chapter which they tell like best practice for performance, etc. And it was cool because they cite a library that is called FFCV. That is basically a library to load images fast. I'm kind of working on a project. So I explore different, ways to load images and labels and stuff. And, also try to learn about, let's say, things that are not usually in the field of machine learning in general, like system engineering thing, like how do you want to load your data in a way that will prevent page fault, and like having things in memory in a sequential way, etc., etc. A lot of time for models that are not very big, the bottleneck is, how fast you can send your data from the CPU to the GPU, right? So I was exploring a little bit about that. There is very few resources about this kind of, let's say, optimization, like how do you build a pipeline. And a lot of times, like, it seems to me that there is no solution for everything, but it depends on the use case, right? If you're working for images on text, how big is your data set? If you can fit that in memory, which augmentation you want to do, etc., etc., etc. Yeah.
Interesting. Yeah, I took a look at it. Like, I didn't go. It's a lot of pages, but I want to get into self-supervised learning more, and I've done some stuff in contrastive learning, but like the DINOv2 is in, like, I didn't understand, like, they had different categories for like how they saw self-supervised learning and so on, and Dino was in one of them. I don't remember exactly how they saw the field, but yeah, that one was interesting to, like, I'm gonna go through that at some point in more depth.
Yeah, like Dino is super cool. Like, it's super cool for user point of view, because they not only train a model like in a self-supervised way that seems to work well, but they also distill the pre-trained model in the smallest one. So you can also have a VAT small that is around 20 million parameters, and it seems to perform as well as the VAT in clip, but the base one that is around.
Let me do this. Let me do this. I'll share my screen if this works, and maybe you can do like we can do a walkthrough of it, and you can. Can you see this?
Yeah.
Okay, cool.
Sweet.
All right, so DINOv2. Actually, I have not read like DINOv1. I definitely should do that.
Yeah, I read that at some point. I don't recall too much. Yeah, like, I mean, the goal is that they're saying, like, they want to be able to have a model that is very good at representing data from images, right? And then basically you can take this model and build stuff upon it for different kind of tasks, like classification, detection, segmentation, etc. Like in Vision, these kind of models that you use to extract good features for images are called the backbones. Yeah. And then you usually, like in segmentation and detection, you take the backbone, you take some features from the backbone. It can just be the last one. Like in VATs, you don't usually want to take the ones in the middles because VAT has no reduction in space. So it's different, from a CNN. Like you start and in each stage, you're going to increase the number of channels and reducing the number of spatial dimensions. But in VAT, you would just have a batch, a sequence length, and a batch size, and you get the same thing out of the VAT. Then, like usually, you take the features, you place them in something that is called an ec that will just, try to refine the features, and then you send them to a head to do the task that you want to do.
So just to understand, so this is basically self-supervised learning on images, right? To learn sort of a backbone network, or to learn to have good features.
Is that right?
And they use a vision transformer.
Yeah.
Okay. And how did they because what's the training step is like?
So if you go down at a certain point, they have a list of all the loss functions that they use.
So wait, they have uncurated data and they have some curated data.
Yeah. So there are two key components. So first is how you create a good data set, and then all the tricks that they use to train the model. That is basically a collection of different criterions for different papers, etc. And so here, basically, assuming you have a data set with images that were annotated and curated, etc. I don't know, the ImageNet one, right? You have 1 million images, that they will be curated, labeled, the distribution is okay, etc. And then you have a huge number of images that may be from, internet, scraping, etc., etc. And basically, you want to create a data set that is still curated, but you want to add the images from the set that, you just scrape. So here, the idea is that you have curated data and uncurated one. You embed each image, and then in the deduplication step, you remove the images that are very similar to each other in the uncurated data.
Okay.
Right.
So how do you do that? Like some cosine similarity thing?
Something similar that they use a method from another paper that I'm not familiar with, but it's something similar to that. Like if you want to do in a naive way, I think you can just do, because there's similarity or stuff like that. I mean, here the key components are, you have a model that is good at embedding this kind of data, right?
Yeah.
So yeah.
So and then remove those two that are similar.
Yeah. And then in the retrieval part, basically you want to get images that are similar in semantic to the ones that you have in the curated data. So assuming that you have you have some images with dogs and cats, in a curated way, then you have a lot of images from dogs and cats, and you basically want to take images that are similar to yours to create a data set with more images. Yeah, so they do this kind of stuff to a data set with better quality, I guess. I don't think they it would have been cool if you try to train a model with the curated one and with the resulting from this method here. So the augmented curated one on the right, and you also train a model with all the images, and you see. But I think for time reasons they haven't done it. But here it's interesting because in text as well, it seems that having good data is the key, right? And we have seen that in text as well, that, you don't really need to throw too much data, but you need to have good data, right? To have something that is good at the end.
So this is basically just some data processing to get better data. And then how did they actually like train it?
So if you go up, sorry, at the bullet point that here. So down on step 4, on section 4. Yeah, so here they have a list of losses and that they have implemented to train this this model. So it's similar to Dino, that this guess is similar to BEAL, in which you have a model and then you have a lagging copy of the same model that is basically the same model, but behind. With the exponential moving coverage of the same weight. And basically, you pass an image, you augment the image, and you send the 2 images through the 2 models, and then you do something with the features from the 2 models.
Okay, so this is one. They just take the same image, they send it through some augmentation, and do some.
Yeah, it's slightly more complicated by that because. If I remember correctly, like the teacher model gets only images with global augmentation. That I guess means an augmentation that preserves most of the image, like a random flip. While the students can get images from something called local augmentation, so like I guess a crop or something similar. And that basically the goal is try to match the semantic. So like the overall stuff that is going on the image. And then they also have this patch level objective.
We don't have to go too much in depth, by the way, but I'm just curious sort of to get, I think I already have like somewhat of an understanding, but it's interesting to go sort of more in depth. But basically they do some augmentation on the image here and like in a more sophisticated way. And then patch level objective, they mask input images given to the student, but not to the teacher. So basically it's like smart image augmentation, right? Or like they have, those are basically those 2. And then, so like they want those embedding to be close. Is that the goal there?
Yeah, I guess that's the idea. And like the image level, so basically I guess like you don't mask the image, right? So like you just want to have the same kind of semantic knowledge of the image to be the same in the patch level 1. Right. Like if you want specific parts on the image to be the same, so like more pixel wise, I guess. And then they have all these methods here that I'm not really familiar with, like the 𝐒𝐞𝐫 centering. I don't know.
It's not okay, but then they do some efficient implementation of that, and then they train it for a long time, I guess. All right. It was, I mean, okay, like I just wanted to get an understanding of this, like what it was about. But I understand, like from reading the like there was the self-supervised learning cookbook. I'm just curious to look at that, because in that one they mentioned Dino, and they said that it wasn't based on a like contrastive learning objective or something. Or I don't know.
Like by contrastive learning, like I guess you mean that you take 2 modalities and you try to use to right, or like by contrastive learning, like you mean that you have like positive pairs and negative pairs, and you use.
Yeah, I guess. Okay, so I mean, like, okay, yeah. So you have, but in that case, like for Dino, I guess what they did, right, is that they wanted to bring. They did augmentation of the same image, and then they wanted to bring those embeddings close in some way, right?
I guess one of the first methods to do something similar is BEAL, and like the issue of doing that is that
self-distillation. Okay. So I guess if when you use a teacher-student, that's when it's called, when it's in the BEAL Dino category. And then you have SimClare and so on, which is the contrastive learning.
Yeah, and like to my understanding, the art part with this kind of process, like with the SimCR, etc., is that like how do you sample the negative, right? That is not trivial.
Yeah, you need to do some.
While with BO, DO, etc., one problem that you may have is that the model may try to cheat, and just collapse on one single representation, and and that, I guess, why having the teacher as a lagging representation of the students may help. But yeah.
Okay. They say a mapping one to the other by means of a predictor. So we have the two encoders in this case would be the teacher and the student, right? And we feed two different views. In this case, that would be, image masked and another one.
It might just be, an image, you do a random flip and you do a random crop, right?
And then they say to prevent the encoder from collapsing by predicting a constant for any input, various techniques are employed. A common approach to prevent is to update two encoder weights with one of the two encoder weights with a running average of the other encoder weight. So that's what we saw with that you talked about.
I would like to know why that works so well, mathematically, why that is the case. Because it seems like an empirical thing that you can just try, but mathematically, why does it work? I don't know. I'm not so smart.
It prevents collapse.
Yeah.
Yeah, I mean, I know that some people, or they looked at using a running average of weights as an ensemble method, basically, right? And so maybe, I don't know exactly. It would be. I mean, it feels like there are so many things that we don't really know why they work, right?
They just work.
Yeah,
but one of the issue with this method is you need to keep both models in memory, right? I mean, it's true that for the teacher you don't need to have the gradients, that model, but still, you need to keep both, two models in memory at the same time. That maybe.
So Biol was the first one in this kind of category, I guess, with self-distillation, and then they talk about Dino some.
And I actually use Biol in practice. I have a lot of documents from shipping company, they kind of scan image. By using, it was 3 years ago, so there were not too many kind of models out there. I was trying to do some clustering with the ResNet 50 trained on ImageNet. It was kind of working, but not too well. So I ran Biol on the images, and it was a little bit, it was better. And the cool thing is that you don't need to do anything, right? You just have your images there, and it works like magic.
I feel like having knowledge of self-supervised learning approaches is becoming more and more important. If we know about that, then we can be much more efficient, because in many cases there are limited data, especially if you're doing some type of project for a company or something, and they want a specific task, then it might be very difficult to fine-tune specifically on that, but it might be very easy to sort of do self-supervised learning and then do fine-tuning on the labeled data that they have, and then you get a lot better results.
And from a user point of view, you have all these models that have been trained on a lot of images, and you should not use the classic model pre-trained on ImageNet, and you should use the ones self-supervised trained, because they are just better, it's a free performance game, right?
Yeah. All right, so let's go. We checked a little bit on Dino, and let's go through the list. I was thinking the harnessing the power of LLMs in practice, a survey on ChatGPT and beyond. I thought that one could be interesting, to get an overview of different language models, large language models. I mean, it's been the hot topic for a while now.
There are so many of them now.
Yeah. They
There is the new stable Vicuna, 13 billion parameters. That seems to be
Wizard.
The Wizard LLM. I mean, it's so cool because they're all trying to do the same thing, but with some slight kind of variation of how you fine tune it. It's very, very interesting.
So can we do an overview? So let's see. You had after ChatGPT, you had was it llama? Llama was, and then you had alpaca, who was like, because llama didn't release the instruction data set, right? So you had you had the alpaca from Stanford with some data set, but they didn't release the data set.
No, they released the data set, but you can't use for commercial.
All right, users. Not weights. Okay.
Yeah, and the data set was basically created using GPT 3.5.
Yeah.
You know, and then at some point so then they got Vicuna that was fine-tuned on, I guess, the data from a website. I think it was called Shared GTP, in which people can just go on the website and upload their conversation with GPT, with ChatGPT, or maybe even GPT-4, not sure. So they scrape that and they train on that. And then, then they had.
So this is Vicuna, by the way.
Yeah, I think it's Vicuna. Yeah, and then there was Dolly 2 from Databricks, right? In which they use their employees to create a data set and then train on that. Then there was the Bloomer GPT that I don't really know the usage for that, but that's, I guess, was just pre-trained on financial data. It was not like instruction fine-tuned. And then the one from Stability AI, that was kind of okay. Then the new one, the Stability Vicuna, Wizard LM.
Yeah, we're gonna look at that one.
Yeah,
as well. That was one of the latest ones.
I'm forgetting.
But then, like, have you checked the Open Assistant, by the way?
I watched the video and the videos from Yannick. I still have to use it. So there is a very cool video. I think it's 2-3 hours where Yannick just coded the backend. That was very interesting to watch, because he took this open source code from Hugging Face, in which they have a backend, some API based kind of backend that it was written in Rust, and then they have another kind of let's say a micro service, which you have the blue models and GPU, and he wanted to inject, like, to change the code of the generated text in the model to basically be able to stream the tokens, So
okay.
So basically you can just create a stream HTTP request to the backend, and you get back the stream of tokens, similar to how you will do that on chat, GPT, etc. It was very interesting to watch. Still have to try that. And then there is another project from an Italian YouTuber, machine learning engineer, etc., that is called Stregatto, that in English is I don't remember the word in English, is the cat that is in the book and movie Alice in Wonderland.
Mm-hmm.
That's also like an interesting open source project. And I'm not sure if I think we are 100% missing some models. But it's also, it's hard to evaluate them. I've seen that people try to score them using GPT-4. That, in my opinion, is not a bad idea, right? Because, like, under the assumption that GPT-4 is the best model that we have so far, it's not a bad idea, to.
How much better is it? Like, have you tried? Like, how much better is GPT-4 than these?
So like. If you try to run like a Vicuna or stable Vicuna with LLM, etc., like, for me, the hardest part is how do I get the right prompt to make it behave like a chatbot, because a lot of time, like, I try to make it like behave like a chatbot, but then it like try to generate, the reply and then the user interaction, then the reply to that one, etc., etc. So I'm not really, I don't know too much about text and prompts, etc. But I guess in that case, having the right instruction, that you actually use to prompt the model is the key.
Yeah.
Yeah,
I
so
saw this one, by the way, that might be interesting from Lightning. They did like a comparison of these language models. Like here they have like a
okay.
like if they're like DALL-E V2, you have these GPTJ and like all these all learned from
So DALL-E V2
Luther.
is commercial. Didn't know that.
And then I guess you have these Llama, Alpaca, and
Yeah, all the old ones like OPT from
Bloom
Meta,
and
Bloom, the GPT-J.
they did. I don't know. Like I guess if we just go quickly, like to go check what they takeaways. Open source models, Flan T5 are pretty good at answering simple questions. Let's see. Llama 7B was decent at explaining. Like I still want to go. Like I haven't actually. It would be interesting to play around with these and sort of make comparison with GPT-4 and see like how much better or worse like they are.
Yeah, like the issue is that we don't know the prompt for GPT-4, right? So like I fear that if you don't have a fair way to, to compare how you prompt a model, it's very easy, to not get, I guess, the full picture, right? And yeah, I don't know.
It says here like the private models like GPT-3 and GPT-4 were amazing, giving us super detailed summaries and even cracking some jokes, but they are pricey and definitely not the best choice if you're working with sensitive information. I also feel like another limitation of GPT-4 and so on is like it's. I mean, you mentioned this on LinkedIn as well as like it's super, like it's always gonna say like I'm sorry I can't do that, I can't do this, I can't do that. Like it's super limited in what you can ask it to
and
do.
also for text, for coding as well. So now my new go-to way to when I need to code something and I want to to make the model code something for me is I go ahead and ask a question and then I immediately say, are you sure? And then almost 90% of the time will say, oh, I apologize for the confusion, blah, 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 blah. But like, as soon as you try to do something that is slightly hard to do, it just fails. It fails. It's amazing. While I feel like I have basically an infinite loop of him trying to code something for me and me, looking at that and, finding some mistakes, say, this is wrong. Can you fix that for me? Say, apologies, blah, blah, and then introduce a new mistake. And like the more you go in the conversation, and I think the more like it gets confused by all the context with the wrong stuff that it generated before. So yeah. I mean, that's I don't know. It's a limitation. I don't know if that can be solved though. I also did an experiment, right? So I wanted to see if GPT-4 can basically run internally the code that it generated to me. But in order to do that, like you should not use something that you may have seen in the train set. So like assuming that you write I don't know, like you say, hey, can you tell me the output of this Python code? And you say print foo, and it will probably say foo, right? Because probably something that he knows, he has seen that. So I create a code in Python that it basically has a Caesar cipher in it. So just a dictionary with a letter that is mapped to another one, like A to C, B to Z, etc., etc., and a function in Python that just take a string and encode it, and then another one that just take the encoded string and encode it, and they say like, can you encode the string for me? And it always fails. Like it's not able to use that previous code. And I try in different ways, more example, blah blah blah, easier cipher with less characters. It's not able to do that. And I was very surprised about that, right? Because I would assume that shouldn't be able, to do something similar. Also because the cipher is simple and it's right there in the context. Yeah.
Especially for something sentient. I feel like it should be higher quality than that.
Yeah. So like when people see that it's able to give you the output of some code, I think most of the times it's just that he has already seen, you know, something similar in the data set. I would be cool to know. Would be cool to know.
All right, so let's go through this the first paper then. I saw a lot of hype for this one on. Yeah, let me know if you want to share. By the way, I can take this one. So we have, you can see it.
Yeah,
harnessing the power of LLMs in practice, a survey on ChatGPT and beyond. This was just a few days ago, I guess 3 days ago. But yeah, I saw, like, I guess how we can do this is let's just read through the abstract, and then
we jump around,
and we just skim through and like get an overview, and then if there is anything like we want to go deeper on and sort of understand, we can do that. But let's go through the abstract. I think that's usually valuable. So this paper presents a comprehensive and practical guide for practitioners and end users working with large language models in their downstream natural language processing tasks. We provide discussions and insights into the usage of LLMs from the perspectives of models, data, and downstream tasks. Firstly, we offer an introduction and brief summary of current GPT and BERT-style LLMs. Then we discuss the influence of pre-training data, training data, and test data. Most importantly, we provide a detailed discussion about the use and non-use of LLMs for various language processing tasks, such as knowledge-intensive tasks, traditional natural language understanding tasks, natural language generation tasks, emergent abilities, and considerations for specific tasks. We present various use cases and non-use cases to illustrate the practical applications and limitations of LLMs in real-world scenarios. I think this is good, right? Because there's a lot of people who are like, LLMs can do everything, they're sentient, and they're obviously not. So it's good to get like a survey of this or like an overview. We also try to understand the importance of data and the specific challenges associated with each NLP task. Furthermore, we explore the impact of spurious biases on LLMs and delve into other essential considerations such as efficiency, cost, latency, to ensure a comprehensive understanding of deploying LLMs in practice. This comprehensive guide aims to provide researchers and practitioners with valuable insights and best practices for working with LLMs, thereby enabling the successful implementation of these models in a wide range of NLP tasks. And then they have a list of practical guide on their GitHub. All right, so I mean, so basically that gives an understanding. Like, it's basically a survey of how to use LLMs, like what are they good for, and I guess like an overview of GPT and BERT style LLMs and how they're different and so on. But like, let's go. We won't read through all of this. Obviously, we'll just skim it, and then we can get like an overview. And if there's something specific, then we can go back.
Yeah, but like, in my opinion, it's always I don't know. I always feel a little bit confused when I see this kind of guides on tutorial about this technology, because like how can you create a comprehensive guide on something we don't know how it works? Like it's I guess you can do a lot of good things, but at the same part, like the core understanding of the technology is missing. So it's very hard. It's very hard.
Like the paper, what was it? The paper where they were like, I didn't read through that paper in detail, but it was like they simulated GPTs in a game. Right?
Yeah, that's so cool. That's so cool. But like in that case, the language model works well because it's very good at text, like on a with different personas, etc. But at the same time, you don't really know how it works, like under the hood. I mean, I guess it's not just a matter, to know the technology in which how it was trained or what data, etc. But like also understanding like why transformer works so well, with this kind of training. It's weird. Yeah,
But I agree with you. Like probably we're gonna figure some stuff out in like 2 months that they can do that. It like it's a comprehensive review of what we know
yeah,
currently.
yeah.
It's gonna change. But yeah, so like okay, they say like in recent years, blah blah blah, like LLMs are
That's the usual
they're talking about
sentence
AGI.
in each paper that he plays.
What?
I
Sorry?
mean the first sentence there, it's always the same one for each paper that is
Yeah.
published now.
And then let's see. So they talk about their work, introduction to LLMs, GPT and BERT. Like I'm just skimming through this. I don't think we need to. Let me know if you see something of interest.
I'm skimming through at the same time.
So okay, they have practical guides for natural language understanding, natural language generation, knowledge-intensive tasks, reasoning ability.
This is, I mean, it looks like it's a great paper, for people who wants to start, be interested in this tech, because here, you have all the language models, etc., and you can just start, you go start, you read this, and then if you see something that you don't know, you search on Google. Seems very, very good.
So they have decoder only, like they talk about decoder only, encoder only, and encoder decoder models. And this, like I saw this one on LinkedIn.
Yeah.
A lot of people talked about this one. This one is interesting. So you have like decoder only. This is like predicting the next, the next token based on the previous ones. And it only looks backwards, like how the decoder is. It's masked, right? So it only sees the previous when it does its prediction, in compared to encoder and encoder decoder. So this is like GPT, and we can see like this is the most popular one for sure. But encoder decoders are also pretty popular, like with T5 and so on. Like, how would you categorize these? Like decoder only is like GPT like prediction or like next token prediction, and it's good for a lot of different tasks, but like in general for me it seems like encoder decoder is like translation and like question answering systems and so on. Encoder only is like
for the embeddings.
So understanding, and then also for like classification based. Like you can do classification with GPT and stuff, but I feel like this is better because it looks at the entirety of the input. But it looks like it's dying because like here the tree, like it's not moving forward from 2021.
Yeah, I mean, maybe because the embeddings are already really good, but at the same time, I mean, yeah, I don't know, man. I don't know. It's yeah. So I mean, I agree with what you just said. Yeah, there are a lot of models on the right that I don't know about, like
I don't
Minerva.
know.
I have no idea what Minerva is. Claude, that is super new on top. Jurassic 2. That's a nice name for a model. I like that. I mean, like I think that all the names from Google are kind of lame. Yeah.
Yeah, like I don't know. There's so many. Like I feel like I mean, obviously, like GPT, all the GPT ones, and then I know about Bloom. Let's see.
There is Bloom
Llama.
Z. I don't know the difference from Bloom and Bloom Z. Maybe Bloom Z is like Bloom, but trained with more data or better. I don't know.
And then they're like, if it's like open, it's if it's closed, then it's white in the middle.
Oh. Yeah.
So I guess like there are a lot of ones that are from Google. It seems like a lot of them are closed. Like pretty much everyone. Is there one from Google that's open? Oh no.
I mean,
like okay, the encoder decoders.
On the left there is BERT. So like we need to give credit to Google because they
True.
implement, you know, the BERT model that is like, I guess, a foundational model for a lot of stuff. Yeah.
Which ones would you rank? Like, if you would rank the companies, like currently, Google, Meta, OpenAI, and which ones are others?
I mean, it depends on the score. Like, if you want to rank them based on innovation, I guess OpenAI and Meta, right? I guess like Meta is, you know, creating a lot of different kind of models, you know, at the same time, while I guess they have like bigger research teams capacity, and OpenAI, you know, they just do one thing very well. But if we like, you know, think about greediness, like I guess Meta is the winner here because they just give you the code and the weights most of the time. And I'm pretty sure de-leaking of the Llama models, the leaking from the engineer Pierre, who leaked the link to the torrent, the magnet link. I mean, to me, I think that was intentional. Like, how come it was a mistake? You know, I think it wasn't. I mean, it must have been intentional. That's my opinion. Like, it's
like, we can hope. I hope so.
Yeah. But you know, like you know, also the stuff from Hugging Face is pretty cool, because probably the only European company that was able to train a model of that size. It's kind of unlucky, because if you look at Bloom and DoPT, you know, they basically trained two very similar models, but Meta, I think they released the model like 2 weeks before Bloom training was done. So I guess that was kind of unlucky, because like basically you have two models that I guess are very similar, but the Hugging Face one, you know, they released all the data set, you know, so you can actually see all the data. I don't think from APT the data set is so.
Have you tried it? You're talking about Hugging GPT?
No, I'm talking on the middle, on the right branch, you know, there is Bloom and DoPT.
Yeah.
And they're basically if you go down, Bloom and DoPT, so they are basically the same thing, more or less, right? So two open source big transformer, you know, that they were trained on data, etc. And I think OPT was released like 2 weeks before Bloom was trained.
Oh, okay.
So that was, I guess, unlucky. But I think here, Bloom is the only model from a European company, you know, that was trained in Europe, because Bloom was trained on the French supercomputer. So that was.
What's the company?
That's
for this?
From Hugging Face.
Oh, that's Hugging Face?
Oh, it's a Bloom. Yeah. It's the open science project, I think. I think, you know, they were able to pull that off. And at the time, you know, it was still not so mainstream. So like you really need a lot of kind of knowledge to do that. So that was super cool.
That's cool. Have you tried from 𝐒𝐴𝐿𝐿 as well? I guess there's like they are honorable mention here.
Yeah, I think I tried something in some demo online, but you know, like from the unskilled high, you know, they more or less look similar, right? You know, you put some text and they give you something back. More or less, they look similar. So I guess if you don't really have a strict approach with the right prompts, you know, and the right kind of questions and benchmark, I don't know. It's hard to tell the difference, more or less.
I didn't find, like, when trying out these ones, honestly, I tried a lot with, I didn't run GPT Neo X, but I tried a lot with GPT-J. I think it's 6 billion parameters. This was a while ago, but I didn't find that maybe it was bad prompt engineering, but I didn't get it to work that well.
Yeah, I don't think it's instruction based though, right? So
no.
That seems to be like the discriminator there. As soon as you fine tune with the structure, it just is better, you know, following structure. I guess.
I hope that they release it. I mean, they're probably going to release.
There is one actually. I think it was one of the few models. So somebody actually, I think on GPT-J, somebody has fine-tuned that one on some instruction data. I'm pretty sure of that. And Yeah, I don't remember the name of the model.
Do you pay, by the way, for ChatGPT Plus?
Yeah.
Because I saw like some people. That's why I sent you that sort of the ChatGPT UI. I know you didn't like it because it was Django, but apparently like it's
cool.
A lot cheaper.
It's cool. Yeah. So but I mean, I don't have the APIs for GPT-4. Like, I pay for GPT just because I can use GPT-4. I only use in GPT-4 and not use the default one because it's just so much better. Like, it's on another
it's level. A lot better. But you only have 25 per hour or something.
Yeah.
I sent you, by the way, you can use that key and you can set it up with the UI. Honestly, I find that it's a lot because in the ChatGPT UI you can't set the temperature.
Yeah, right? You can't. And you can like no? You can't. And like the tab on the left side with all the chats, etc. I think I like 150 chats, and it's I can search on the chats, right? Like,
I'll show you. By the way, wait. So I'll show you because this one was the one I fixed for today. Like, I was just playing around with it, but I saw that someone said basically that you can basically with ChatGPT API, it's a lot cheaper. You can generate like a Harry Potter book in equivalent every day for a month, and it would still be less pricing than ChatGPT Plus.
Ooh. Okay. Yeah.
And here you can use like GPT-4 and you can set the temperature. And I kind of like that they had like you could do like maps, like different folders.
That's really nice. And another cool thing is that you can just get an API key yourself, host it like on a Raspberry Pi or your computer or on a server, and you share it with all your family and friends.
Right? This, by the way, was they had, let me see, so ChatGPT UI, here we go. So this was the one. Like all, wait. No, it's not this one.
Yeah, this is the one that you sent me.
But it wasn't.
Oh.
Here, this is the one. Okay, so here they had like, you could do like this deploy with Vercel.
So no, wait, it's not in Django. It's in Next.js. So I guess the one before that is the one that you sent me, and this is the one. Yeah, if you go up, so let's see. Do they have? If you go in pages, so that should be the stuff from Next.js. Yeah. So this is in Next.js. So yeah, I like this one more.
Okay.
So it's super easy to self-host there. It's a one-click self-host on Vercel. And I mean,
I really like that one.
Yeah, man.
Actually,
look at how much stuff. They also have a Kubernetes folder. Damn. So some crazy stuff going on there.
Let me share let's go back to the paper.
Yeah.
All right. So let's see. They OpenAI consistently, blah blah, Meta, which was interesting. Those were the two you mentioned as well. So encoder, decoder. We talked a little bit about encoder, decoder, and encoder only, decoder only. BERT is kind of the main go-to for encoder only models. All right. So they have practical guide for data.
I mean,
generalize.
The first point is true for vision as well, like with self supervised model. Yeah.
And I mean, LLMs are preferable to fine-tune when working with limited annotated data. Why is that, do you think? Is it because like you can adapt to specific structures in the data?
So are preferable to fine-tune models when working with... So I think that's because they've seen a lot of stuff, right? So they generalize way better, with new data. Like, I mean, I guess if you want to yeah, to find a similar thing in vision. Like it's like if you train a model on image of cats and dogs, you know, to do image classification, and then you have new data, the background is different from the train set. So maybe all your images were in a house, indoor, and now you have images from outdoors. Maybe, yeah, maybe that will confuse the model. But if you use you know, big models that have seen a lot of stuff, probably you know, won't be so confused. Yeah, and I think that nowadays you don't want to go ahead and fine tune the whole model. Maybe you just want to do something similar to LoRa or adapters or this kind of stuff. Because I read something about the catastrophic forgetting. That is an interesting interesting two words that basically looks like that if you take something and you fine tune it, you may are going to change some weights and make the model forget about. But if you use some method like LoRa chattering, which basically you keep the same weight and you basically inject new information on it, more or less, that should be, I guess, safer.
Yeah, I'm super scared of that when fine tuning. Like, how much am I making? Because like I can make it completely horrible, right? If I mean, like as you said, it can ruin the previous information it has.
Yeah, or yeah, I guess I don't know. I don't know how to. You know, I just know how to fine tune this model. You know, with you know, if I have to do that, I will just fine tune with LoRa. You know, but I guess you can also maybe freeze everything and just fine tune the last layer. I guess. I don't know, just from a make sense point of view. All
right, so let's go through, because we have a lot of papers. We're not going to be able to go through them. Let's say how long this is. We have been 1 hour. Let's say maybe it will take like 1 hour more, so 2 hours, and then we'll try to go through and to go through them. All right, so they have like pre-training data. Yeah, I don't know. I guess plays a pivotal role.
Yeah.
Fine-tuning data. So they have 3 scenarios if you're going to fine-tune. 0 annotated data. What's that? In scenarios where annotated is unavailable, utilizing LLMs in a zero shot proves to be the most suitable approach. Oh, okay, so you have like
there we go. The
zero shot learning
forgetting.
So where did you see that?
The next sentence. No, sorry. Guap. Yeah.
Additionally,
the absence of a parameter update process ensure that catastrophic forgetting is avoided since the language model parameters remain unaltered. Yeah.
So this is like zero shot learning.
Yeah.
Or is that what they're talking about?
Yeah, I really like the word catastrophic forgetting.
It's a nice word. Yeah, I mean, and then what, like few annotates, like few shot learning, and then abundant annotated with a substantial amount. Both fine-tune and LLMs can be considered. Yeah, okay. I mean, like this is very overview, right?
Yeah, so,
test data, user data. Recent advancement has been RLHF. Yeah. All right. So practical guide. So here, I guess they try to give you like a guide for what to use
NLU task. What's an NLU task?
Traditional
NLU tasks.
Natural language understanding.
Okay.
So they do. So yeah. So natural language understanding would be text classification. I guess maybe like sentiment analysis, named entity recognition, entailment prediction. I don't know what that is. Entailment.
No idea.
Actually, don't know. But yeah, so like I guess.
Yeah, like I guess the most basic stuff that people were used to do with language, I guess.
So here they have like a nice graph of
that's nice.
Like what to use when, I guess. So how does this work?
So I guess we start from the top left, right?
Yeah.
Mimicking human. LLMs, yes. No. Man, I'm so confused with this graph.
So I guess like if you have like an NLP application, if you wanted to mimic a human, then you go to LLMs.
Okay.
If you don't want it to mimic a human, but it requires reasoning ability, then you go to LLMs again. And if you don't, then if you're gonna multiple tasks, like if you're not gonna have very simple task for it,
Okay.
then you use LLMs. Otherwise, tasks with little relation to language modeling, e.g. regression. I don't understand. What would be NLP application with regression? A bit confused over this one. Like, what does this entail?
Mm-hmm.
But if you do want that,
like maybe you want to predict a score based on a review of a movie, right?
okay.
Maybe.
But would that be NLP?
I guess.
Oh, okay.
Yeah, I guess yes. Maybe yeah. Or like I mean, still, if you want to do sentiment analysis, I guess you just predict class, but that will be a regression, I guess. No.
Okay. So so if you would do like movie, like sentiment analysis, and you would want to have like a floating value,
something like that, I guess.
Then you go to fine tune. But if you don't want that,
just a few label data here. If you just have just a few label data, then you go with our language models.
Okay. And if you
but then I mean, so now I guess we have a little bit of an issue in definition. So what is a definition here of a large language model? Because a fine-tuned model is not large, right? By definition it could be, but in this case I'm not sure. So like by large here, it seems that it seems to mean everything that is transformer based, right? But I guess large was introduced to define like models like GPT-3 and so on, right? So a little bit of confused here by.
Yeah, me too. What do they actually mean by like where is the difference between fine-tuned models and LLMs, I guess, is the question. Like, where do you draw this distinction?
So I guess to me, I'm not an expert, but I guess fine-tune models is something that you can fine-tune on a single GPU that is, it's a good one. Like a single fine-tune on a 100, right? But still, you can fine-tune a 7 billion parameter on an A100.
So let's say this is like basically like a very small.
Yeah, smaller model.
Okay. Yes. Like BERT or something.
I guess, yeah. I guess. You just, you just attach something on top, a head, something.
Basically, I mean, like the takeaway from this graph
or
this like this decision flow is that LLMs are powerful and are used for a lot of tasks. I guess
go broom, yeah.
Yeah, for sure. I mean, that's like the takeaway here. Let's see. I guess their remark here: fine-tuned models generally have better choice than LLMs in traditional NLU tasks, but LLMs can provide help while requiring strong generalization ability. So like if you want to do sentiment analysis or you want to do named entity recognition or something like some type of classification tasks, then maybe you can just use BERT or something,
I guess.
And otherwise use LLMs. I guess that's like their takeaway. I don't know.
Yeah, so glue and super glue. So I know that glue is a metric that you use, but I don't really know how it works in practice. So I know it's something that allows you to, have a sentence and you have a target sentence, and you're able to check how similar they are. But I don't know how glue, is actually, how it works.
Me neither. I don't know exactly how it. I mean, there are different. I feel like there are so many different scoring metrics, or like that you can. Oh wait, this is. Wait, this is
a task. No. Wait. No. So glue is a task.
Oh, okay.
No, wait. So,
It's not a
so what
metric.
was
Okay,
the
whatever.
name of the metric? That I think it's something similar to glue. I'm not sure. Or
I mean, you have
maybe
the.
is a task that is used as a metric to evaluate. I don't know, man. I don't know. I don't know too much about text, but yeah,
I mean, you have the blue score, I guess.
yeah,
But
yeah.
GLUE,
Blue,
General
yeah.
Language Understanding Evaluation Benchmark, is a collection of resources for training evaluation. Okay, sorry, that was my bad. Okay, so it's like a. But what? Okay. All right, and then they have. I think I've seen glue as a metric though. Oh, okay, but it's like evaluated on.
Yeah, like the correct name of the metric is BDU, right?
Okay, man, I need to catch up on this.
Yeah.
I'm okay, but okay. So let's go back, anyways. So all right, so they like on those tasks, fine-tuned models still have better performance. But yeah. What are they actually trying to say here? No use case in. What do they mean?
I guess
no use. I don't understand.
I don't know.
I'm confused. So wait, here they're like traditional NLU tasks. Like they're saying it's better. Fine-tuned models are generally better, but then they say no use case. In most NLU tasks. In text classification, LLMs perform slightly worse than fine-tuned. For sentiment analysis, they perform equally well.
Really, for text classification, in most that, yeah. I mean, yeah. I mean, it depends on the classes, I guess, and what you want to do. Toxicity, the detection, and the gap is much larger. LLM cannot perform. Yeah, it's weird. I mean, they cannot perform well because they have be fine-tuned in a way that makes them avoid toxicity, so they cannot really process the text because toxicity seems a very easy thing to spot, right? In general.
Yeah. I mean, like, it makes sense to, like, basically in general, that for these kinds of tasks, then you would want to have something that is like an encoder-only model, right? Because you would want more information of the entirety of the sentence rather than doing sort of a next word prediction thing. Like like for text classification.
Yeah, but I mean, you can just say, hey, like, give me a score for 1 to 10, or
Yeah, of course, yeah. But maybe there's like,
but then it's low, right? Of course.
Maybe it's just that the structure of having the entirety gives better information in some way, and then it's, I don't know. I guess, I mean, it makes sense in some way too that you would. That's my thought process on like why they would be better on NLU tasks, and that LLMs doesn't perform as well or like equally well.
Yeah, like I mean, in my opinion, if you have some data, you have some labels, you can just go ahead and try to fine-tune a model, one post match, and and see if that is working well.
So then they say here also that like it's basically like better, fine-tuned model is better from the performance of the computational cost, and so the scale is usually 10 or 100 times larger than fine-tuned models, so you can have a much smaller one that performs equally as well or even better for those specific tasks. But yeah, it seems like LLMs are taking over more and more. I mean, from this graph, right? Like there's a lot of if statements where you go to LLMs here.
Yeah, but I think that before that it was not even kind of possible to do the tasks there, like mimic human behavior, etc. Without having this kind of models. Yeah, like in general, yeah.
Yeah, it's pretty like, I don't want to go in too many tangents, but like, have you been playing around much with like Auto GPT and like
No. So
LangChains?
like with all the auto GPT, I think there is maybe AGI and auto GPT, right? No, I haven't, because I haven't found a use case for me yet.
Yeah,
I
me
I
neither.
seen some video online. It seems cool, but I seen from the video, people that they were using it in testing, so there is no benefit for me to go ahead and use it for myself because I don't have a use case. And
Yeah, same.
but yeah, but what I would like to do that would be so cool would be to do something similar to the paper in which they have like the video game with the persons were going around and interactive,
Mm-hmm.
but basically having a way to have different words, and also
Mm-hmm.
for me to go there and interact as well, and also to mimic some social experiments that people have done in the past, like behave like social behavioral experiments in which like maybe you have a prison, and like of course you need to use a model that was not that doesn't have a firewall, doesn't have a strong ethics fine tuning, and you miss
Mm-hmm.
basically. I would like to see if I have a prison, I have some agents, who are like the guards and other total like kind
Mm-hmm.
of models, who are the prisoners. How long will it take, for the guards to commit some crimes on the prisoners? Because for humans in the right environment, it takes very few days. So it would be interesting, like to have this kind of experiments. It would be very interesting, in my opinion. But yeah, I would love to have a day that is like 1 hours long, but but yeah, it's
Yeah. I haven't tried it out either, but it feels like it's pretty interesting what you can do with it.
yes.
And also pretty scary to just hook it up to the, like, make it do whatever it wants,
But
basically.
thing that I would like to do is create a tool for LangChain for Google Calendar. So I can just say, hey, I need to do this, like I want to learn this thing, then I need to go to the gym 2 hours a day, blah, 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 blah. And then it just schedule like all the calendar for me. And then I can go ahead and say, no, like today, I feel like I would like to do this thing before that. Can you rearrange that for
Yeah.
me? So that would be super cool, right? So like,
I mean, it's just a matter of time, right? Until we have Jarvis.
yeah,
Like, Jarvis will come soon, I feel like. Right? Don't you think? Like,
yeah.
it's not that many steps left. I feel like it's gonna be pretty
Yeah, I mean,
soon.
the issue is the hallucination problem. That's the issue. That's the big issue.
Yeah.
If you can just, I don't say remove the hallucination, but, don't say anything instead of hallucinating, that would be so much better. But
You need
not,
to change like the underlying training, I think, because
yeah,
it's like it's trained for plausibility,
yeah.
and it's gonna
It's
make
just
shit up,
gonna
I think.
generate, yeah, it's just gonna generate some text based on the context, right? So that's it. Yeah.
Yeah, I don't know, like what they here when you have a use case. Uh, I don't understand. Like, okay, I guess like I'm missing something. Like they said no use case and then use case.
I
There's
say
something that I
so.
missed.
So what if we jump to the section? I think there is a section in which they will talk about the issues, the bad things, and the dangers, of these models. That would be
Yeah. So I mean,
interesting.
this is we can skip this. Abilities regarding scaling. Um, let's see. Exponential increase. They become better at common sense reasoning. All right. So what are the use cases with reasoning? Common sense reasoning.
Yeah, the emergent abilities. It's a very interesting topic. So, for what I understood is that it's not really linked completely to the number of parameters, right? But it's also linked to the data. So like better data may create a new ability in the model, right?
Yeah. Let's see. So
that's a very good paper. I mean, it's more like a book, right?
yeah, or I mean, like it's like an overview,
Yeah,
I guess.
overview.
But
Yeah.
yeah. Let's see. So, is there anything here that we want to talk about? Like, okay, so you have in the last part, we would like discuss the usage and fine-tuning real-world tasks. What if you have noisy, unstructured input, tasks that are formalized by academia, following user instruction? I wonder if they talk anything about like prompting and so on here, or
See.
Okay, so here they just talk like which models to use, or let's see, they talk about. So without any formalized task or metric, the evaluation of model can only rely on feedback from human labelers. Okay. Other considerations. Okay, light local fine-tuned models should be considered rather than LLMs who are sensitive to cost or have strict latency requirements. Zero-shot approach of LLMs prohibits the learning of shortcuts from task-specific data sets. This is actually a pretty big thing, right? Like in general, it seems like it can learn to be specific to the data set. We saw this from the Whisper paper as well, I think, or like a lot of papers, but I remember specifically from that one, they talked about it. Sort of having out of distribution performance. All right, then safety concerns associated with LLMs. Yeah, okay, here, given the utmost importance as the potentially harmful or biased outputs and hallucination from LLMs can result in severe consequences. I mean, like, this is pretty scary. Like, people talking about using like LLMs for like to replace like doctors. Like, I saw that. Did you see that? Like,
yeah. So like my take on that is like, so a lot of comments is from people who have no idea how this stack actually, is implemented, right? How it works, and they just see the output. Maybe they try it, but they're not really into this kind of stuff. But at the same time, what you could do is say, okay, so it's true that it's very hard for normal people to find fairly good medical advice, right? So maybe like I want to Google, for a little pain how they have, etc. It's very hard to find something that makes sense. Like, I usually go, if I know that I may have something specific, I go on PubMed, right? And I search for that, and I try to read some medical papers. So at least I get an understanding of what this actually is. But I guess that's not for everyone. So, if you have some system that is like a content retrieval system, which you have embeddings of medical stuff, you ask a question, so like you really know which data is linked to your question, then it's a very good thing. But if you have something that can suffer from hallucination, it's a bad thing. And some people say, it's better than nothing. I don't have a thesis in that, but I'm not sure that having something that can tell you a lie is better than not having something. I don't know. And
yeah, I don't know either. Like, I mean, if you could hook it up with some type of like PubMed, and then it could search and so on, and it could learn. And even people are talking about sort of, instead of just prompting it in context with different information, like it could, like you could also like fine tune it. If you could in future like fine tune it real time, sort of on that specific data, like you could ask it like, read these articles, like train it on that, fine tune it, and then you could prompt ask it. But even then, maybe it will still, you could increase the trustability of it, but it could still generate like bullshit. And what if it's for a really important thing, like it's gonna classify a medical problem, or even
But like here, for instance, if I have a little pain or I don't feel well, I need to go to the translation in English is something like base medic, It's like a generic one, you know. And if you say to him, hey, you know, O'Hare, I have some pain in the shoulder, it's just going to send you to do an MRI on the shoulder or an X-ray, etc. You know, and I think there are a lot of examples, you know, of like questions that people have and simple stuff that you need to do, you know, that like, why should I go to a generic one? You know, if I have a little pain on my spine, I know already that probably I should call the hospital and say, you know, I want to do an MRI, you know, and then I will have there the expert for the specific, you know, issue that may be in the spine. It doesn't make any sense to go to the generic one and pay him for him to send you to take an appointment, right? So like for this kind of things, I guess it would be beneficial, but probably could be something that is used from an hospital as well. So like, yeah, you know, like, you know, you have his kind of pain, you know, you may want to do this, like you may want to call this specific specialist, etc., etc.
I mean, it's also like the general problem with AI, where what if it performs well in general? Like it is, let's say it is better than a doctor in general, but then sometimes it does really bad advice and somebody dies.
To pay, yeah. I was going, yeah.
Yeah, so like, I mean, it's the same thing. I don't know how like Tesla does it, but like if you have a self-driving car and it's like in general it's safer than humans, but sometimes like it doesn't see, like it does a misclassification and it just continues driving and somebody dies. Like who is liable? It seems like that's the general issue.
So like in my opinion, you should never use this kind of stuff, you know, for something which there should be a real human that, you know, is liable, right? So yeah.
Okay. So basically, like you should have, like your argument is that you should have like basically GitHub Copilot, where we are coding, but we're using Copilot or we're using GPT, but you're the one responsible for the code, right? You're writing the code.
I am the one responsible for the code, right? Like I am the coder. That's it, just a tool. Like in the same way, I don't need to know how physical memory on my computer is implemented, right? I can just allocate stuff on the heap and call it a day. The same thing, I may want to use a tool that I don't know how it works under the hood, but I need to be in charge of that, right? So the difference there is that, you know, we know that memory is implemented in a smart way, and we know we know how it's actually implemented and why it works, you know. These methods, we don't know how they're implemented because they are closed from GPT and we don't know how they work. So it's even more, to me, you know, I feel that a lot of people at the beginning, they will say, you know, programmers are dead. But to me, it's even more important to be a programmer now, because you need to have the strong domain knowledge to be able to really, you know, to use this tool in a good way. Now, I don't want to say in a good way, but in a productive way. If you don't know what you're doing at this moment in time, you know, as soon as you have an issue, you have no idea, right? You have completely no idea. So yeah, so I mean, programmers, I guess, are even more important. I mean, if the only thing that you can do is write some very basic HTML code, then of course, you know, it's easy for the moment to mimic that because it's an easy task. So it probably have seen, it has seen tons of stuff on the internet, but from everything else, from everything else, like you need to know what you're doing.
Yeah. It's an interesting, I feel like it's people are talking about this a lot, like using these models for all kinds of applications, like even GPT-4. I mean, it was performing better than lawyers, right? In 90 percentile in the bar. But what if it replaces like a lawyer, then it gives like bad advice for like, I mean, it's like how, I mean, I don't know. It's
but I mean, it probably saw the data set on, you know, on the training data, right? So for questions, etc. about law, I don't know how the exam actually work,
right? But also on the other hand, like most cases that come up like in law, they are probably copy pasted like with some slight variation of like a million different cases in the past.
Yeah, but I mean, I think it depends on the country, right? Because I guess from the knowledge that I have of how law works in the United States, that is from, TV series,
Right,
like there you can cite an old case, blah, blah, blah. But like in Italy or in Switzerland, for example, I mean, you can still cite the whole case, but it doesn't mean that the same rule has to be applied. And and then still you need to have somebody that is liable for, right? And so at the beginning I was really impressed. I was also thinking, oh man, it's done, GG. It was nice to be a programmer, but the more I use, the more I realize how overhyped the whole thing is. So to me, when I see people around who are saying this is going to replace programmer, for me it's just because they have not really used the tool yet.
But it's a great tool.
It's a great tool. It's a great tool.
It improves my efficiency. Talking about efficiency, like probably 2x, I would say.
For me, no. I mean, it depends on what you're coding. So if you're coding something that has a lot of verbose stuff, like web application, right? Maybe you need to every time code a React component, set the state, blah blah blah. It's kind of it's cumbersome. Then for sure. If you need to code something that is not long but has to be a specific medium to hard logic inside, then it's not going to work well. I mean, it can give. So I usually go ahead and try to ask for my question, just to see what is going to tell me, to have like an inspiration. Like, so especially in PyTorch, maybe sometimes it's going to use a weird function that I don't know about. So I go ahead and look for that. It's also a nice way to be able to, be exposed to more stuff.
Like different libraries.
Yeah. But then it's hard to trust it. Yeah.
Yeah. All right, man. Let's go. Let's say I think we should probably be more efficient. Like we need to be like on these papers, like we'll go through I usually go through papers more in depth, and I feel like we're doing like semi in depth now, but we should probably like go be okay with missing a lot of stuff. Like probably like you can probably get a decent understanding of a paper in like 10-15 minutes, and then we could look at many papers. All right, so like latency for LLMs, let's see, trustworthiness. Yeah, this is like this is like interesting because we talked exactly about this just now. Like healthcare, finance, and law. It is ensure that they're trustworthy, robustness and calibration.
See that. Yeah. I mean, the fairness and bias. That's to me. So the fairness and bias is such a hard topic, especially in 2023. But it's really, so in my opinion, it's so hard because biases and fairness, they have a global meaning, so like don't be a liar, don't insult people. But also depending on the society you are inside, they shift. So the same bias that maybe not, so like the same ethics that I have in Switzerland, in Italy, may be different to the ethics that people have in China or Japan, right, or some country in the United States. So, and then like usually here, and I have seen some other papers studying biases and fairness on Stable Diffusion, right? They usually always assume that the right ethics is the Western one on some specific countries, but I'm not an expert, but I guess it depends. So it's very hard. And usually all the trained data, especially for vision, they come from Western stuff because we have the internet, a lot of people in different countries have bad governments, they don't have internet, that, blah, blah, blah. Yeah, so that's another very hard question.
Super hard. I don't know if there are good answers to it.
No, also because, like the interpretation that we give to what is right or wrong change. It's I don't know the right word in English, but it's something that changed through time. So what we think is right now, maybe won't we write in 10 years, in 2 years, like, for instance, I'm 27, and something that was okay 15 years ago, now it's not okay, right? So it's very hard. It's very hard.
Yeah, for sure. I agree with you, and I don't know. It would be interesting to get thoughts on how, like, from someone that works specifically on these topics, like LLMs and bias, and how they like basically like what problems there are and like how they are trying to solve them, because it seems like a lot of people are going after the data, right? But we can't. But then there are also like different architecture changes
after the data. So like, to me, it's cool to train a model with everything we have, because it's going, like, given a specific kind of time frame, like in the last 5 years or 10 years, because then it's going to be something that represents the world, right? In the wrong and in the good things. And then it could be, something that you can study to understand, how people are thinking about stuff, right? In general. But I guess, I don't know specifically, but if I were to try to fix a bias, I would probably go ahead and introduce my own ones, right? As a European person, and so it's hard, I guess. I don't know, man.
I would not like to be working in that area.
Oh no,
like
me
it's
neither.
Too difficult.
So the safety alignment. Safety alignment since what's safety alignment? It's the last one. It's the last one in the bullet point.
Yeah.
Safety alignment.
The safe development of advanced AI. I mean, like, I feel like what we're doing now with Auto GPT and like hooking it up to the internet and letting it explore recursively and so on, I feel like it's that's a disastrous way. Like for GPT-4, like it's probably fine, but imagine doing that in the future. Like if we build more and more complex models.
I mean, it depends on what the model can do. So I mean, here you just kill the script. He has no memory, right? I mean, you can still hook to database. You turn on.
Yeah, but if you give it access, like if you give it access to your terminal, it access to the internet. I mean, we're not there yet.
Yeah.
So
I mean, it's in the same way, like you should not go ahead and download the random script and run it, right? You should not let your terminal be run by something that you don't know what it's going to do.
Yeah, but no, I'm not talking about for you. I'm talking about like for existential, like what they're talking about, like existential risks for like humanity.
So like, in my opinion, it's more probable that we're gonna to nuke each other than the machine to take over.
Yeah,
I guess, but still, I have no idea. Because maybe now in a lab somewhere there is the new attention V2 that is just so much better, and I mean, who knows? We don't know.
I feel like a lot of people are, I don't know if you've listened to like Max Tegmark or Elon even is raising a lot of like talk about this.
Yeah, but I don't know about Elon. I think he missed the train this time. And but I agree on that. You shouldn't train blah 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 blah. And I think there was like 50% of people who were just there because they were missing the train, and 50% of people who really know a lot of stuff about this. That we're basically saying, we should understand how these things really work, and then if you want, and then we take over from that, right?
What do we take from this paper, by the way? Like for me, it was like an interesting paper of like that gives an overview of like architectures for transformers. It had a nice figure of like different like what year things came out, like a good overview of that. Difference between like what were decoder only, encoder decoder architectures. And then I don't know, like the decision flow chart. I don't know how useful that is. Like my takeaway from that is LLMs are powerful and they are probably best for most cases, unless you need very good like cost efficiency or low latency. Then you can use some other for natural language understanding tasks, so sentiment analysis, and so on. Yeah, I don't know what else. Like, what
Yeah,
do we
I
take
think
from
this
this
is a
paper?
great paper. If you just want to know more about this kind of tech, this is, I think, it's great because I think it covers all the important parts, and it gives you a good overview on the technology, the limitations, the history. And yeah, I think it's great. It's great.
A big limitation is practical use, though. Like, they don't talk anything about prompt engineering and so on. Like, how do we get them to work well? I feel like that's missing a little bit.
Yeah, that's for sure. Yeah, I mean all the yeah. That's yeah. Maybe we skip that, but I think yeah. I think I haven't seen that.
I didn't see
Yeah, me
anything
neither.
about prompt engineering, but maybe we missed that part. But that would be like, it gives an overview of LLMs in general. So it was pretty good, I would say.
Yeah, it was.
Do you want to take the next one?
Yeah. Can we do 2 minutes break? That be okay?
Yeah, let's do
Yeah,
that.
super.
Yeah.
I'm gonna.
Mm.
Okay, can you hear me?
Yo, yeah.
Okay, so let me try to find it was tracking everything, right? Or was segmenting everything at once, yeah. No, sorry, this is 2032. And tracking everything, everywhere, all at once, that I think. There is a movie, yeah, that is, it's everything, everywhere, all at once, that I've seen it. It's nice, but it's too long. No, it's
like to showcases it.
This segment. No, there is a movie. So I think they took the title of the paper from a movie that is called Everything, Everywhere, All at Once. And you want to look at segment Everything, Everywhere, All at Once.
Oh, I've seen that movie.
Yeah,
that movie is good.
But I think it's too, like, towards the end is too long.
yeah, true.
But but it's I mean, it was something original, something very original. So
that's where the title come from?
I mean, it's the same thing. I mean, it's the same word. So I'm gonna say I'm downloading the paper. Give me a sec. Okay. Saving to disk. Okay, my God. They should make some sort of a dark mode for PDFs because they're just too wide.
Yeah, there should be. Probably. But yeah, it's true.
Can I share a specific screen? Okay, nice. It's this one, right?
Let me see. Yeah.
Okay. Segment everything, everywhere, all at once. From the University of Wisconsin and Microsoft. Know about the other institutions. So the abstract. Despite the growing demand for interactive AI systems, there have been few comprehensive studies on human-AI interaction in visual understanding, e.g. segmentation. Inspired by the development of prompt-based universal interface for large language models, this paper presents SAM, or maybe SIM, how it's pronounced, I don't know, promotable interactive model for segment everything, everywhere, all at once in an image. SAM has four data. First, versatility by introducing a versatile prompt engine for different types of prompt, including points, boxes, scribbles, masks, text, and referred regions of another image. Two, compositionality by learning a joint visual semantic space for visual and textual prompts to compose queries on the fly for inference, as shown in figure 1. 3, interactivity by incorporating learnable memory prompts to retain dialogue history information via mask guide cross attention. And 4, semantic awareness by using a text encoder to encode text queries and mask label for open vocabulary segmentation. A comprehensive empirical study is performed to validate the effectiveness of SAM on various segmentation tasks. SAM shows a strong capability of generalizing to unseen user intent as it learns to compose prompts from different types in a unified representation space. In addition, SAM can effectively handle multiple rounds of interaction with a lightweight prompt decoder. The SAM demo is available, blah, 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 and the source code will be released at the same place. Okay, so this was a long one.
Yeah. Yeah. Like what did it actually give us? Like it So it has the huge data set, right? Like this paper.
Yeah. So yeah. This is the first time I see the paper. So I think I saw a video, that was just able to, to track a lot of stuff, and you can do a lot of things, but I'm not so familiar to the capabilities, So it looks like that. So let me zoom here. We have, connecting segmentation is a segmentation, semantic segmentation, point box, that I guess that you can click on it, and it will show you the segmentation. You can click on it, and you can place a box, and it will show you the segmentation. Scribble, I don't know what Scribble means in this case. Text, audio, cross style. Okay, so the same thing in 2 styles. Text view visual, the largest bar, and no prompt. Yeah. I'm sorry, I should have read in this way. So this is, you don't have a prompt here, and it's going to do the panoptic, the instance, and the semantic. You have a prompt here. Okay. So there is a point, mask here. There is a box, the dog of Minecraft. Yeah.
Okay, now the scribble makes sense.
Yeah. And yeah. Oh yeah, so it can do everything. Damn.
I mean, that makes sense.
That's cool, though.
Like the title makes sense.
Okay, so let's see. I'm gonna say introduction usually. So this is the usual phrase that now it's mandatory to each paper.
Yeah.
So I say the introduction. We don't. So by interactive image detection or segmentation, it means that you interact with the image. So you put a point, you put a box, or you do whatever you want. But like it needs to have some sort of user prompt interaction, right? So I'm gonna say maybe we go right. Okay, maybe we can read from here, because this seems to have, to be like some introduction. So I guess, let's see. In this work, we advocate universe interface for segmenting everything everywhere with multimodal prompts. To achieve this goal, we propose a new prompting scheme that has 4 important properties: versatility, compositionality, interactivity, and semantic awareness. Yeah, same things from the abstract. For versatility, we propose to encode mask point, points, mask text boxes, and even a refer region of another image that are seemingly heterogeneous into prompts in the same joint visual semantic space. As such, our model can deal with any combination of the input prompts, leading to strong compositionality. So it means that you can have more prompts at the same time, I guess. Like you can have a box, a bounding box, a point, or other stuff. To enable interactivity, we further introduce memory prompts for condensing the previous segmentation information, followed by communication with other prompts. So I guess by interactivity, you mean that you interact with the previous one. Like I guess you put a point, you receive a mask, then maybe you want to place another point to have another region incorporate in that mask. Maybe you want to remove a region, etc. I guess.
I don't understand how they trained this. Like, what's the data? Like, how did they...
So let's do like that. So let's go on the method. Here we go. Method, right. So Sam is pronounced Sam or Sim? No idea. I need some help here, man. You are from Sweden, right? So yeah. You should be the best English speaker in Europe. Only second to the UK, right?
Yeah. I mean, UK is not in EU. I mean, like, I don't know, like Sim.
Okay.
Sim
employs a generic encoder-decoder architecture, but specifically features features a sophisticated interaction between queries and prompt, and shown is figure 3. So let's go and look at figure 3. Okay. Oh boy. So I guess here we need to see. We need to start. We have a text encoder. We have an image encoder. Then we have an arrow that goes to the visual sampler that is taking this kind of prompts here. Then we have this joint image text representation space that we don't know what it is yet, but I guess somehow there is some kind of cross attention between all these features. And then we get from this one, we get the learnable queries, image features, text prompts, memory prompt, and visual prompt. And then we put them.
So just concatenate, or?
I have no idea, but no. I guess yes, and you place them in a decoder. From the decoder, you get the class embeddings. I don't know yet what they are, and the mask embeddings. Now, in the decoder, it looks like there is some specific self-attention. So like it looks like only some type of queries can see the others. Like here, it looks like that the green one, that are the learnable queries, can, I guess this means that, I guess this means that all these others attend the queries, or that the queries can see the others. I don't know. I guess we will have to read the method. I
mean, it says self-attention, so I guess like everything.
Yeah, but everything is connected here. How come, we don't see anything going on the others and vice versa? So it could be some sort of mask self-attention. Yeah. And we have some cross-attention. Yeah, between the, I don't know, like we need to read that. And here in the visual sampler, we take the image features, guess from this thing here, looks like, and you create something that is the visual prompt. This is very high level. And then the human model interaction is that we have the image text encoder, right? Yeah. This is done only once, and then we just continue to basically pass, I guess, to recompute the visual prompt here, right? This part.
So we go back to like the input.
Yeah.
So they send in a class/sentence. So like we have, from an image, we have, what could an example be of what we have?
I don't know. It's also interesting because like here, if you see, so from this one, we have the image features, right? And this is the text prompt. So I guess it's linked to the text encoder. Here we have the queries, but why this is here and not there, by following the logic here.
Yeah.
So, and then I don't know. I mean, because you can also, it looks like that you can also prompt with a text, right? If we go on top, you can prompt with a text, right? A text prompt, the person in blue. But I mean, you can also avoid that. So I'm kind of curious, like, to see more in detail how this actually work. This join image interpretation, and from here, how do you like what do you actually do? Like what do you do with the class embeddings, right? If that's for supervised, I don't know. So maybe so let's have a look, right? So we say give it an input image I, or height, width, and 3 channels. An image encoder is first used to extract image feature Z. Then SIM decoder predicts the mask chem and semantic concept C based on the query output O, MH and OCH. Okay, so this M, I think it stands for mask, and TC for class. The H, I guess, hidden, class embeddings that interact with visualization, text, and memory prompts. So in the decoder, sorry, so wait a second, text memory prompt, PTO, P, Q, and PM. So in the decoder, I guess these are QH.
Some query.
Yeah, it's the query. Here, the image feature. We predict the visual text and memory prompts. No, that interact, right? Okay. Yeah.
So wait, we send in a query, and we give it the image features.
Yeah, and
we get what?
And we get the two so the mask embeddings and the
embeddings.
And
what's PT
so these
and
are
PV?
the visual text and memory prompts. You know, they interact with it. That interact with visual. So yeah.
So what's the input exactly? Like the input is.
So the input.
Like to me, the input is just an image and a text. Or
yeah, I mean here for looking at this, it looks like the input is all the stuff here, right? So the image. So assuming that the decoder here is the same decoder there, right? So yeah, we have the learnable queries. The three P's are the text prompt, the visual prompts, and memory prompt. Z is the image. So I'm not sure why this is written in this way, but I guess because these are computed from the image, right? Not the text though, yes.
Is there a demo, by the way? Maybe a demo would make it easier to understand.
It's let's see.
Like how it works.
Try Hugging Face demo. Yeah, let me.
I think there should be
a
demo.
Yeah, it's yeah, see that. I need to change my window screen. Okay, let me. Sorry for the. Okay. Do they have an example? Okay. Let's go with Minecraft. So let's see if I go with text and I say the pig, right? Then I should just be able to submit.
What? Oh, okay.
Yeah, it's the background.
It says start draw.
Yeah, so it's no. So I don't. Okay, so maybe we don't need that. Like, we don't need. Oh boy. Oh boy. Sorry. Let me refresh.
Wait, referring text.
Yeah, I mean here the 4G.
But it says like start drawing. Like you can draw on the example.
I think I can draw. So let me just run the default example so we can validate that it's working. Okay. So then I think I can remove this. I draw here, and then I submit.
And you can do it in multiple ways. You can do the scribble, you can do the box, you can do the.
I can also
dot.
I think I can also remove this and just place a point there. Yeah.
Man, this is super cool.
Yeah. So
and then you can also do.
Going back to the Minecraft example, I can place a point on the peak, right, and it should work.
Right.
No, it doesn't like the Minecraft example, I guess. So let's try this. I place a point on the front. Damn, they look really good.
Yeah, I'm pretty hungry now too. Like that would be what?
Yeah,
but do the scribble thing then, because it failed, right?
Yeah, but then I guess we could. That should be interactive, right? So I don't think that here they have the interactivity. Yeah, but maybe I can just do like this, right?
Are we using it wrong, or is it like
right? No, but I mean it's also supposed to be interactive, so it means that then you go ahead and you if I just because like we can also do the scribble on the.
Yeah, I don't understand. Why do we have, wait.
So this is so like I can use this as a prompt, to say, hey, I want T stuff on this image, right?
Oh, okay.
So if I do that, food. Yeah, but
okay, and if you remove the referring, like if you don't have a referring image,
here I just
and you just have text,
the fries error. So it looks like it fails without the referring. So maybe it can just be.
Oh, do you have to have it?
No, I don't know, but I think it's just a plug in the code though. Yeah, but so let me reset it. But so what do you think is going to happen if I do this? Is it going to highlight the background or? Okay, error. Refreshing.
Maybe try this. Maybe try the segment anything demo on. Like, I don't know if this is Hugging Face or if it's the model, because there's another one.
Like you mean the one from segment anything?
Yeah, this one.
Sorry. Where is there a chat here? Sorry, or did you send me?
No, this one. This one. Try the demo.
Yeah. Oh, yep. I accept. Where's the demo?
It's on the top.
Apologies.
Yeah.
Oh. Yeah, I mean, like.
So they extract the image features.
Yeah, but this is a different approach.
Okay.
So basically here, we are just predicting. So we are extracting the image feature, and then from the feature, based on what you do, we're going to predict the mask in the region that you are highlighting. So like here, I can go ahead. I can say I don't want this yellow stuff. I click there. Or maybe I need to click with the right one. Yeah, and now I remove it. Right. And then maybe. So yeah. So let me go back. Maybe. Yeah. Yeah. Like for instance, so if I click, so yeah, like assuming I click in here, so I get in the full person here, right? So now the model under the hood, so probably, I mean, it's predicting the full person mask and the jacket mask, right? But it doesn't know what you want, right? So now I can go ahead and remove the pants, and now I get my jacket, right? And then maybe assuming I just want to have the top, maybe I add this as well. Now I get the top. This is usually like normal interactive segmentation, in which you do this kind of point things. Here is cool because you can also use a bounding box, right?
This is new to me, by the way. I have not played around with these types of models.
No, I mean, the powerful thing about this specific one model is that it's very good. That's the new thing, right? That this is very good.
Yeah.
And
I'm curious, how it works. How did they train it, and how did they do this? Because it's super cool.
Yeah, so basically, so what you want to do is train, you click on something and you generate a mask, in order to have the labels, you can create the points that will be associated to a mask if you have the ground truth. To do so, they have created a huge data set with mask, a lot of mask, like 1 billion plus mask, right? And then they train the usual VAT like model with some cool transformer decoder that can take the points as input and then bounding box as well.
And how did they get the data set? How did
they created it?
Oh, they they labeled all of this?
Yeah, in a semi supervised way. So they label a little bit, and then they train the model, and the model label a little bit, and then they label it again, blah blah blah. It's crazy.
Because it seems like a lot of work, like an insane
meta.
amount of work.
Yeah.
Yeah.
So basically here you have the image encoder, you know, the usual image embedding. So like you need to compute the embedding only once per the image, and then you can do whatever you want. And basically here you can take some different things. So like you can take the points, the box. You could also use the text, but they're not, I mean, they still have to release that part. And you encode these as tokens, and then you pass to the decoder. And what you get out is, damn, I'm sorry, I need to, yeah. And then if you see here, for the scissor, you get different mask for the same object, because we don't know which part you want, right? So if I click on the scissor, I may want the full thing, or just the hand grip, or just the lower, I'm gonna call it the hand grip. I don't know the right word. Yeah. And the cool thing about that is like they built this huge data set. And that's why it works so, I mean, it works so well because it's also smart, but it works so well because they have this huge data set. Yeah. You know, it's really big. It's like, you know, here saying it's 6 times bigger than the usual ones.
So can you get the names of those masks?
No. So this is just going to show to segment stuff, right? But then, you know, you can do a lot of interesting things, right? So you can crop what you have and run it through creep, right? And maybe do a zero-shot image. You know, you segment the image and then you classify that. Imagine if the embeddings that you have here, you know, were something that, you know, was trained on clip. So you also have the text alignment, and you could actually, I guess, train an alignment layer to align the embeddings here to the text encoder to clip. So then, you know, you just need to compute the embedding once, and then I guess you can do whatever you want. Oh, no, because then you will have to recompute the embedding for the, but
there are multiple like things I don't really understand. Like, first of all, how does 1 billion masks make sense? Like, how could there be 1 billion masks? Like, how could that be possible?
It's a lot of stuff. So they have 11 million images. So they have 100. They have 100 masks per image on average. I hope my math is correct. It will start to be a little bit tired, man. So that makes sense. This is a nice paper, right? The paper is actually nice, and the most interesting part from say engineering point of view is to understand this specific part, right?
But if we just zoom out, so what's the input? The input is an image, and the input is a prompt.
Yeah, I mean, you can also not pass a prompt, right?
Oh, right, okay. Yeah, because you have the referring image as well. Like, how does
No. Wait. This is a different model. So this is SAM, right? So wait, maybe we're doing, so we have SAM and we have SIM. Okay. Yeah. So like this is the demo. So it's a similar model. Now the difference, for what I understood so far, is that SIM can do things with more prompts, while SAM only works with points and boxes so far. It should also be work with text, but they don't have the ways for that.
Okay, now I understand. Okay, so you have like segment anything, and then on top of that they built a SIEM, and then now we have TrackAnything, which was for videos.
So TrackAnything is on top of SAM, if I'm not mistaken, but SIEM is different.
Separate.
SIEM, you know, the architecture here. I'm sorry. Oh my god. I need to reshare the other screen. So the architecture for SIEM is different, because screen. Here we go. So here, yeah. So in, can you see my cursor?
Yeah.
Yeah. So like in SAM, so the one that we just saw meta, you encode the image, just the image, and then basically you take the embeddings, you know, and you build up your prompts as tokens, and you take the embeddings to a transformer decoder that takes the prompts as input, right? While here, it looks like, you know, you build your features, and, you know, to build the prompts, you use the features, right? And then you do this joint image representation space. So it's slightly different because to build the prompts for SAM, you don't use the image encoder. Like you don't use features from the images, they are just prompt. So I'm not sure what's going on here, to be honest with you. I'm not sure.
Okay, so let's see, because I think if we go to just SAM, this was the segment anything was, I don't know, it was earlier, right? Than C.
Yeah, like
it was before
1 month before.
Yeah.
This is so new, right? This is just 1 week ago.
This was like
2 weeks ago.
Okay, and then for segment anything, can we go look at that one? I think it's a simpler architecture, right?
I mean, depends how you define simple. Yeah, let me get the paper. Like people,
because I was like, how does it do? I thought it was the same model, and then that like you could send like you could press like what you want, but you could also do it with an image and then refer back. But yeah, I was
no. What I mean, because you know they use similar names, you know. Yeah. So let me see what you can see from me. Okay. So I need to then I need to screen, window, and cement everything. Damn. And now, no. Oh my god! I shared the previous one. And sorry.
It's okay.
Cement everything. Okay. Oh, am I? Boy. Okay.
I'm opening it too.
Okay. So, yeah. So the issue with this paper is that if you really want to know how the model is implemented, you need to go in the appendix. Okay. So basically here, damn, Ubuntu, come on. Where it was? Yeah, and like, look at this. This is some flexing from Meta, right? Look at this. That's perfect. It's perfect. Look at the Kumba, I guess. Cucumbers. Oh, yeah. Okay, so
that's insane, man.
It's very cool. Okay, so yeah, same image as before. Now here, if we look at the, let's say,
so what's the mask there? Like the mask points, box,
so these are all self-explanatory because these are the points on the image, the box that you draw, and you can also use it with text, but they haven't released the code for the text part because they use the encoder from clip. But since the number of dimension is different from what this encoder takes, they for sure have trained an adapter like in the middle. But I checked the code and there is no code for that.
So the code you can use is only that you press and then you draw a box.
But
okay, and if you can choose, I guess you can do both,
I
or
think
you can
that
choose.
You can also draw a mask, right? I guess so. So let me check. So let's see. The prompt encoder, we consider two sets of prompts: sparse, points, boxes, and text, and dense mask. We represent points and boxes by position encodings, some with learn embedding for each prompt type, and free-form text with an off-the-shelf text encoder for clip. So Okay, so somehow they get some positional encoding, because like points and boxes, they represent a position in the image, right? So they create a positional encoding for that for these sparse prompts, and then sum them to a learnable embedding that the model has learned during training. That dense prompts. So yeah, so you can pass a mask to it, an embedding using a convolution, and some element wise with the image embedding. Okay. So basically, if you get a mask, you embed with a convolution, then you sum up with the image encoder. That, I guess, because like you want to mask some part of the image somehow. But this is if you really want to look.
Wait, why did you get 3 outputs, by the way?
Because the model is going to predict multiple masks.
Okay.
Yeah. And with a score. So you're gonna have different score, I think.
How many? Is it
yeah,
fixed,
I guess
or?
it should be fixed. I guess by the number of I guess by the sequence length. I guess, but let's go and look at the appendix because there they explain so much better. I read it like 2 weeks ago, so probably not remember anything. So this is the architecture. So basically, what you have 2 layers of, let's say, decoder model with the self-attention across the prompt tokens and the output tokens that I don't remember what they are, but we will have a look at them. And then you have an attention from the token to the image embeddings, right? And notice that the dimension of the embeddings is kind of small. They have been reduced, right? This is just 256. But they use a VAT with embedding size of 768, and then they reduce the embedding. So to me, at that point, I mean, why you can just train with 256? But I think because they use something that they have already pre-trained on something else. And then they have the image to token attention. Then what you do, this is similar to mask former to some degree. So what you do is like you have 2 branches. So in one branch, you go to do an upsampling of this thing, right? Because this is small, right? And you arrive here with a mask that is bigger. I'm sorry, yeah, with a feature that is bigger. And then here you take the features from the image token attention, you pass it here. You take the new can you say the new tokens from the prompts that you self-attend, you attend to the image. It's like, so up to here, all these tokens have seen each other and they have seen the image, right? And then you do an attention between the two. Then another attention between the token and the image, because this time the token will attend to the image that has seen the tokens. Because here, tokens are attending to the image that have not seen the token, and now the token are attending to the image that have seen the token. Now, don't ask me why this is necessary. I don't know. For me, it makes sense, but it's a random thing to do. And yeah, and then basically, then what you get is, I guess this is a number of features that you dot prod to what you have here, and finally you create your final mask. So I guess the number of masks that you can get is based on how many of these you have, and then you also create an output because you want to have a score for each mask. I guess this case the IOU score is how much the mask is supposed to overlap the thing that you want. And yeah, it's a little bit it's convoluted, but at the same time there is just all here, right? And yeah, so they use a VAT huge that is is huge, right? And so the prompt encoder, the sparse prompt are mapped to 256 dimensional vector embeddings as follow. And for sparse prompt, we mean the points, the bounding boxes, and the text. But so just think about points and bounding box. So
okay, but just to like, let's go back to sort of the overview. Okay. So like segment anything, what they did is basically trained on a huge data set with a lot more masks than previous data sets had. It was like 11 million images in total. They like their key, that was like the key contribution, or was there also modeling difference?
So I think it's the data set and the modeling, because the modeling, it's really cool, right? You know, you just need to encode the image once, and the architecture part itself here, assuming that the code is not doing something that they haven't explained, it's cool. It's simple. It's lightweight. It's easy to use.
I'm not familiar with the like previous approaches, so I don't know what's different from previous
approaches. It's usually you have an image that you send through. You attach a new channel with the points that can be represented as a binary thing, so like a Gaussian thing, with the curve that it's brighter in the center, and then it fades away, and then the model is trained to, given an image and a set of points, to generate a mask, right? So that is the old way. So for it, and then each time you generate a new mask, you can include it in the input, and you can also go ahead and include new points, etc. And so the model will relook at the image and the mask that you generated before and the points that you provided, and will generate a new mask for you. And that's useful, like in in companies that they give you a annotation interface. If you want to annotate polygons, it's faster to click around, right? And I click in the center, I had a mask, I don't want to have a specific point, so I remove that, and then I get a new mask, etc. Here, the cool part is that you encode the image once, and you pass the points here, right? So I can pass the first point, and then I have another point, I pass another one, and then I kind of guess that when you generate a mask, assuming that I click on the middle, right? So my point is going here and getting this mask. And then I guess I put this mask here, and then I put a new point, maybe here, and then I get this mask, I guess. That would make sense.
So it's interactive.
Yeah. And so if you have a data set, you can just encode everything once and call it a day, and then you just run this thing on your server. And it's cool.
And let's see, so like previous approaches, did they also have like the text or the text prompting?
Not that I'm familiar with.
So it's kind of like a clip, but for segmentation.
Well? No, I don't know. Like to me, the cool thing is that with the decoder approach in Transform is that you can place here whatever you want, right? So here I can place it whatever I want. Like for TR, that I don't know if you're familiar with, it's a model for object detection, and basically it's similar approach, right? That you have an image encoder, and then you have a transformer decoder, and basically here they have a learnable set of what they call queries that are just collection of tokens. Like you have 100 tokens, and then you get from the decoder 100 tokens, and you use these tokens to find the bounding boxes. Here, if I want to do this thing, I don't need to have that kind of queries. I can just, have points, box, text, or whatever. I can also have an audio, right? It's just, it's more general. Like the transformer architecture is more general. So here you can basically put whatever you want to, and everything will be able, if you want to look at each other, they are able to look at the image, etc., etc. So it's beautiful, in my opinion. But yeah.
Okay, so okay, let's see. So the this was segment anything. That was basically like the usefulness is that, what would you say? Like, what is
the
how would you
summarize? It just works really, really well, and it does not require you to recompute the image embeddings. And it just works so well. It works so well.
And they release the data set
and the model and the weights, and it's for commercial usage. So yeah.
And then on top of this, this was early last month or this month,
April. So the paper, yeah, it's sorry, yeah, 3 weeks.
Okay.
4 weeks ago.
And then we had �EAM,
yeah,
which was everything all at once or something.
Yeah.
And that one basically made the change so that we could use a reference image. And or what was the difference between SAM and
here,
�EAM?
To me, segment. Sorry, they are so confusing in naming, because it's basically
you just give the
it's
name.
Basically the same. So here it looks to me that the model is slightly different. It allows you to have more stuff sent into, but I still have to grasp the idea behind it, like behind the architecture.
I mean, it can do a lot more. It can do a lot more, right?
Here, I mean, you also have the cross style, was interesting, and the text plus visual.
But they're not related. They're not built on top of each other in any way.
No. It looks like no. So I think, I mean, maybe we should look at the data set, because probably. Oh no, it's oh boy, it's trained on 𝐶𝐞𝐫, right? So yeah, so damn, it's trained on 𝐶𝐞𝐫 plus 𝐿VIS or 𝐿VIS, I don't know how you pronounce it, and yeah, similar performance. Okay, so it looks like, by looking at this table, so what it looks like is that with less data, they get similar performance though, but compared to, with some, you don't have the ones on 𝐶𝐞𝐫, etc., but you have the ones on Pascal VOC. It looks like they have better performance than some. I mean, it's remarkable.
And it does a lot more,
it does
right?
A lot
like
more.
�EAM does a lot more.
Sam is the
and this
first,
was not from Meta, or who was this from?
Microsoft, right?
Okay.
Microsoft.
Okay, it would be interesting to see like what people what people use, if it's SAM or �EAM, because they seem to have similar functionality in some ways, right? You can still can you still like interactively click and remove different parts?
In theory, yes, but the demo is not really so polished. So like the cool thing about the Meta one is that they really publish it in a way, that, I mean, like that they thought about it, like, because they made the blog post, they made a super nice demo. I mean, like, the demo itself can be a startup, right? And they create the blog post, they publish the code, and the code is well implemented, and etc. So it means that they really, they plan that. But here, in theory, you should be able to do interactive segmentation. Interactive.
All right, so I think let me I can share, and we can go through the TrackAnything quickly. Like, we won't go through it in the depth, but let me see if I can share.
And then I think we can call it a day, because I think I will eat.
Me too. Yeah. Okay. So let's just. I want to know like how this works. Just like quickly. All right. So segment anything meets video. So this is built on top of SAM. So we have like the SAM one that you can press and you get the segmentation. And then they built TAM, TrackAnything model.
But
I'm reading from here.
Straightforward to do, I guess.
Which achieves high quality performance, interactive tracking, and segmentation in videos. To be detailed, given a video sequence only with very little human participation, i.e. several clicks, people can track anything they're interested in and get satisfactory result in one pass inference. Without additional training, so they don't do any training basically. Like all they do is they use SAM in a smart way, I guess. And this was just released
1 week ago.
Yeah. Okay, so I mean, I'm just gonna go through this quickly, but like, I checked this paper like quickly before, so I have like an idea, but only like 5 minutes or something. But basically, you have like, you have video object tracking (VOS), video object segmentation (VOS), and then let's see. So yeah, basically, what they want to do is they have like a video. Let's see if we have a figure. Yeah. So they have like a video and then you start with like the first frame and you click the one you want to follow. Mm-hmm. And then it uses this 𝐿LM, which is another model that is able to track, like if it knows what to track, it tries to do its best across time to be consistent. So they use this 𝐿LM. But sometimes this 𝐿LM can lose tracking. Like if it loses tracking, it gets very bad. So what you do is that you sometimes in the middle you will click to make sure like this is still the object you want. So you press like you initialize, press which one you want, and then sometimes in the middle it will ask you like which one do you still want to track to keep it consistent.
Okay.
So like you do this like this correction basically, and that's the interactive part. So it like initialize, it tracks this 𝐿LM, but then sometimes it and also like if it's good quality, no,
we segment
then
again.
segmentation, and you correct. So that's basically their idea. So you use initialization with SAM. You track with this 𝐿LM, which I don't know how it works, but we can check if you want. But it's like basically some type of tracking through time. And then you do refinement by clicking again.
So basically you don't run inference with SAM on every frame.
No, you just do SAM a couple of times on like a couple of images, and then 𝐿LM takes care of the rest, I guess.
That's interesting.
So 𝐿LM, well, let's see. Okay, this paper is actually pretty short.
That's nice.
I mean, they didn't do any training or anything. Okay, so here, like segment anything, we looked at this one, right? Has been proposed by Meta and gets numerous attention as a foundation model for image segmentation. It's based on vision transformers, blah, blah, blah. This 𝐿LM, giving the mask description of the target object of the first frame, 𝐿LM can track the object and generate corresponding masks in the subsequent frames.
Okay.
And
so
then
okay.
I don't know about this one, Atkinson's Shiffrin memory model. I don't know what that is, but it aims to solve the difficulties in long-term videos with unified memory stores. So it uses some type of smart memory storage, what it's seen before, and so on. The drawbacks of 𝐿LM are also obvious. As a semi-supervised, what was this? Video object segmentation model. It requires a precise mask to initialize, which SAM is great for. And then for long videos, it is difficult for 𝐿LM to recover from tracking or segmentation failure. And then in this paper, we solve both difficulties by importing interactive tracking with SAM. So I think I like this paper because like they didn't really do anything. Like they just hooked up two models and like two Lego blocks and like, boom, you do this and then it works.
Yeah, but assuming that now you are able to segment using an image as a reference, right? So similar to sim. So now instead of go ahead, instead of stop, instead here to stop the process and prompting you to reselect, you could use the initial mask to try to refine it, right, with the with the model itself. So like in theory, in sim, if you want to track, you may just go ahead and put a click in the first one, and then on every frame, you will try to refine it, right? So that could be interesting to try, actually.
So you would use, like, what were you thinking? Like using
because in sim, you can use an image as a query to find the object that you want.
Right,
so like you click on the, so like there, like you click on the bus, you crop that image, right? And then, or like you keep the image and where you click on it, and that on every frame, you go ahead and you ask sim, where is the image?
Right. Do you think it would be consistent though? Like maybe
I have no idea.
I like from the demo you showed, like from Hugging Face, there was a lot of failure, and like I don't know if it was.
Yeah, but in theory, finding something that you have, from an image query should not be such an hard task from a model, like assuming it was trained well. So like it should be easy, to find something that is very similar to something that I'm giving you. Like it's harder to use text to find stuff, because like you need to encode text, and then you need to adapt, blah blah. So that would be cool to try. And so then
that would, I wonder what like projects you can make from this. I feel like there's a lot of interesting things you can build on top of
and
this.
Then I can make a paper called TrackAnything everywhere all at once or something.
Maybe that's what we will do next time.
It's a 5 minutes personal project.
I mean, I feel like this paper, they didn't really do anything, but it's still a really
super cool paper, because then I saw somebody that tracked like a person using this thing, and then it took the mask and then did the painting with Stable Diffusion, so you removed the person from the video.
Oh damn! Yeah.
But the shadow was still there, so basically you will see like a shadow moving. But it worked. It worked fairly well.
That's so cool.
It worked fairly well.
That's so awesome! Holy crap! That's so.
Yeah. Because like, imagine how useful these segmentation stuff are for in painting, right? Because now it's super. It's easy to click on something, you get a very good mask, and you paint on that, right?
That's awesome. What did you think about our paper? What did you think about paper time with Francesco?
What do you mean? Like
what did you think about this paper?
I think it was very cool. So like you motivated me to have a look at his paper. Yes, I think at least for me, it's harder to read paper all alone. Because it's easier to get distracted, or it's easy to think that you understood, while in reality you just you don't have an understanding.
Yeah, there are probably lots of stuff we missed too. But like I was thinking, like it's cool to just I want to read more papers, and like in general, I want to get a better understanding of what's going on. I mean, I think we got a pretty decent understanding of like just a general overview of them at least. And it would be, we'll probably learn how to do this better, like if we do it in the future, because like there are, like this is the first time, like you obviously, like we get a better structure and so on. I think like generally you can get a pretty decent understanding of a paper in a relatively short amount of time, but you need to like learn how to skim and like what to focus on and so on. But yeah, yeah, I think there are like generally two things I would like to do. I would like to get a better overview of papers and follow research, but then also like dive deeply into specific papers and really try to like understand the code, really try to like build projects on top of it and so on. But so yeah, I really enjoyed going through some papers. It was intense. Like there's so much information, especially like I had not looked at.
Yeah, so like maybe I think for the next time we should like try to have a time limit per paper, right? And I guess like we can use the papers with code trending page, as a list, I guess, because that had, should give us a good idea of what people are interested on, right? And maybe then, yeah, I guess like 15 to 20 minutes per paper, should be enough time to have a good idea. Yeah, the issue with me is that I get a little bit excited about stuff, so I start to talk and I want to know. So yeah, we need to yeah. Mm-hmm. Mm-hmm. Yeah, me too. Yeah, damn, I was reading that. Oh no. No. I mean, for me, it's still recording. I see the red point on the right. Oh boy. Damn. Yeah. So the only thing that I can do is leave. Yeah, I can see that, it's I have the red point and the uploading. Sure. Thanks a lot, man. It was really cool. Yeah, bye. Have a nice one. Bye.